Technomaths. So today we'll be taking two questions from ray optics, where the first question is that the focal length of a concave mirror is given to you. Okay, there is a concave mirror. Okay, and the focal length is given to you. So let's say into the first question. Let me zoom a little. Yes, I think it's better visible to you now, right? So into the first question, it's given that it's a concave mirror. It's a concave mirror, right? And the focal length is given to you as 30 centimeter. So that means we can write the focal length F is given to you as 30 centimeter, right? Now we need to find the two positions of the object in front of the mirror, right? If this is the mirror, which is polished from back side, because this will be the concave, right? We need to find the two positions. What are the two positions of the object? That means the object should be placed in front of it. So what are the two positions of this object that we need to calculate? And the condition is that the positions of the object need to be calculated when it's given that the image is 3 times the size of the object, right? So here the focal length is given to you as 30 centimeter and the image is 3 times, that means its magnification is given to you. Magnification, and you know what, how it is represented? It is represented by a small m, isn't it? If you remember, a small m. Now in this question, the image formed could be real magnified or a virtual magnified, because it is a concave mirror. So the image could be real magnified or virtual magnified, right? These are the two conditions for a concave mirror. This is the condition for image. The image could be real magnified and virtual magnified, right? That means the value of m which is given to you is 3. So basically that will be either plus 3 or minus 3, right? So here, hi Shimya, morning. So the two conditions will be generated based upon these, when m equal to plus 3 and when m equal to minus 3. So for real image, the first condition, so for real image, what happened? We consider m equal to 3, which is nothing but, let's say, for the first case is the ratio of v by u. Since considering the first case, let's say it's v1 by u1, right? Now we know from here we can say v1 is equal to 3 times u1, isn't it? Tell me. Fine. Then apply the formula 1 by f is equal to 1 by u plus 1 by v, right? Sorry. And here we are knowing the value of f, that is 1 by 30 is equal to 1 by u1, and in place of v just write this v1, this one. When you write 3v1 in place of v, it will be v1 as 3u1, you will write in place of v 3u1, 1 by 3u1, right? Now let us just solve it. Here you can see 1 by 30 is equal to 3u1 into the denominator, and here it will be 3, and here it will be 1, and from here 3 will cancel this 30 in 10 times, and you will get the value of u1 is equal to 3 plus 1 4 into 10, or 40 centimeter. Yes, one of the position of the object is calculated, and that is 40 centimeter in front of this, 40 centimeter in front of the mirror. So one position u1 is calculated as plus 40, right? Now just take the second condition, when m equal to minus 3. This is the condition for virtual image, for virtual image. What will happen for virtual image? We will consider the value of m equal to minus 3, because we have already considered m equal to plus 3. So when m equal to minus 3, we can write same as we have written for this, for the real image. Then here, let me write it from green pen. The magnification will be minus 3, and this minus 3 is nothing but the ratio of the image distance by object distance. But into the second case, as we have considered v1 and e1 for the first, let us say it's v2 and u2 here. Hi Hunter Experiment, very good morning. कौन सी क्लास की है? Here it depends, it the light from chapter 12, even in class 9 also. Okay, so it yes, even in 10. So basically, if you are asking this question, so many times I am thinking twice to say yes, which class, because these are the questions which are basic for your preparations. Okay, so yes, these are basic fundamental building questions. From 10 and 12 you can say one liner answer, right? You are right. 10 ka m equal to minus 3 will be v2 by u2, and similarly m equal to, as the value of minus 3 is given to you, so just put it over here, minus 3. For the second case we are calculating minus 3 equal to v2 by u2, and from here minus 3 into u2 will be the value of v2 which we calculated. Now again, using the mirror formula, we will try to calculate the second portion. Derivation, okay, derivation I will sure in a separate session I will bring, definitely. So we will using this formula again, 1 by f equal to 1 by u plus 1 by v, right? So just writing it again, 1 by f equal to 1 by u plus 1 by v. This will give you 1 by 30, as the focal length of 30 is already given to you. 1 by 30 is equal to 1 by u. In place of u, just write u2, and in place of v2, just write minus 3u2. So it will be, the sign of this plus will be changed to minus, because into the denominator it is minus. So we can write by, in place of v2, write 3u2, and this minus comes over here, right? Now let us solve the second part also. So here, when you solve, you get 1 by 30 is equal to 3u2 will be into the denominator, and into the numerator it will be 3 minus 1. So this will give you 3u2 is equal to 3 minus 1 will be 2. 2 into 30 will be 60, right? So this will give you the value of u2 as 60 by 3, that is 20 centimeter, right? So the another image object distance we have calculated, and that is, one was plus 40, another is plus 20 centimeter, right? So these are the two positions of the object in front of the mirror, so that the image is 3 times the size of the object, right? Now students, quickly coming to the second question. This is the second question. What is the second question? The second question is that a convex mirror produces a magnification of 1 by 2 when an object is placed at a distance of 60 centimeter from it. So first of all, let's see the data given into the question. Where are you from? Please reply. Definitely Hunter experiment from India. It's a convex, right? I am from Jharkhand, yes, Dhoni state. It's a convex mirror given to you, and it produces a magnification of 1 by 2. So first of all, write the data. The magnification, the value of m is given to you as 1 by 2, right? When an object is placed at a distance of 60 centimeter from it, that means magnification will be 1 by 2 when the object is placed at a 60 centimeter in front of it. That means u is given to you as 60, right? Now, where should the object be placed so that the size of the image becomes 1 by 3rd that of the object, right? So it's a convex mirror, right? And the question is asked that where should the object be placed so that the size of the image should be. So first of all, the situation is like this. This is a convex mirror which is polished from inside, and the bulging surface is shiny, right? And we need to find the object distance here. We need to find it. The object distance we need to find. So a convex mirror produces a magnification of 1 by 2 when an object, that means you can see magnification of 1 by 2, that is the side of the object is reducing. Okay, the size sorry, the size of the image is reducing, that is 1 by 2, you can see from here, right? So when an object is placed at a distance of 60 centimeter from it, here this is 60, where should the object be placed? Now the question which is asked is, where should the object be placed? What is the new value of u, which, so that the size of the image becomes 1 by third of the object, right? So here you can see magnification is 1 by 2, right? So being a convex, we can write the value of m here as m1, and it will be negative, right? It will be negative minus 1 by 2, because this is a convex mirror magnification. And if you write the image distance, image size by image distance, or image distance by object distance, you just put up the value of this 60 over here, then you get the value of v1 as minus 1 by 2 into 60, which will give you 30, minus 30 centimeter. This is the image distance. Now again use the formula, mirror formula, 1 by f equal to 1 by u plus 1 by v. So here it will be u1 and v1, right? From here what we will have, we will be calculating the focal length. The focal length will be 1 by u1, that is 1 by 60, and in place of v1 minus 30, so this will be minus 1 by 30. This will give you 60, 1 minus 2, or f equal to 60 by minus 1, or minus 60 centimeter is the focal length which we calculated, right? Now it is given that where should the object be placed so that the size of the image becomes 1/3 of the object. The value of the magnification, the second magnification, let us say m2, is given that 1/3 of the object, as its convex and magnification, it will be negative, m2 equal to minus 1 by 3. Here again put up the value. What is the magnification? The ratio of v by u, but this is the second case as given into you into the question, that where should be the object be placed so that the size of the image becomes 1 by 3. So minus 1 by 3 should be equated with the ratio of v by u, and it will be v2 by u2, because already we considered v1 and e1 for the first case, right? Now m2 equal to v2 by u2. So this will give you the relation of v2 with respect to u2. So v2 can be written as minus u2 by 3. Just we will be using this, v2 equal to minus u2 by 3. Now Again use the same formula, mirror formula. 1 by f is equal to 1 by u plus 1 by v. So basically this will be the second case where u2 and v2 is considered. Right here in place of u2, in place of v it's v2. And the focal length we have already calculated earlier. The focal length we have already calculated earlier, and that is equal to minus 60. You can see here. So just put up the value here. This will be minus 1 by 60 in place of 1 by f is equal to 1 by u2. That means 1 by u2, and in place of v2 write minus u2 by 3. So it will be minus 1 by u2 by 3, right? So this will be giving you minus 1 by 60 is equal to 1 by u2 minus 3 by u2, isn't it? Because these three will be going into the numerator, and this will give you minus 1 by 60 is equal to u2 can be taken as LCM, and here 1 minus 3. So this will give you u2 as minus 2 into minus 60, which is nothing but plus 120. So plus 120 centimeter is the value of u2, not image but object. It's the value of u2, right? So this is the object distance where it should be placed in front of the convex mirror, so that the size of the image becomes 1/3 of the object here, right? And this is the answer, students. Thank you so much for watching. Take care. Bye bye. Happy learning. See you.